Okay, so finding non-permissible values, what we are concerned with is division by zero, because we don't know how to divide by zero, and we're not going to show you how in a few years either. We seriously don't. So whenever you have a fraction or a rational expression which has a denominator in it, that denominator must not equal zero. So looking at this thing, we can pick off right away that if 2x minus 5 ever equaled 0, we'd be in trouble. We'd get x minus 3 divided by 0, and that would be undefined. So 2x minus 5 equals 0 would be bad. If we solve that for x, we can take the 5 to the other side and get, if 2x ever equaled 5, that would be bad. And so if we divide both sides by 2, we get, if x ever equaled 5 over 2 or 2.5, that would be bad. So 5 over 2 is one of our non-permissible values. Another one is simply x. If x ever equaled 0, that would be bad. For the same reason, we'd have x plus 1 divided by 0, and we wouldn't know how to calculate that. So there's two non-permissible values, or often we just say NPVs right off the bat. Now, the next thing we have to watch is, in the process of cleaning this up, because we have that division, we would normally do this. X minus 3 over 2x minus 5 times, I'll just use a dot so x's don't get confusing, and then we flip this second expression and we get x over x plus 1. Now, having done that, we now have a new denominator here. We have to worry about this as well. Remember, they said in the notes that if it's a denominator at any stage in the simplification, you have to worry about its non-permissibles. So from this we get, if x plus 1 equaled 0, that would be bad. And so x equals negative 1 would be another bad thing. So our final list of non-permissible values is 5 over 2, 0, and negative 1. For this next one, we have a part here which appears to not be a fraction, but we can make it a fraction by putting it over 1. And now we go looking for our non-permissibles again. 3a is one of our factors in the denominator, so we'd have to have 3a can't be 0. You can either think of this as if it equals 0, then that's a bad thing, or you can say 3a is never allowed to be 0, which amounts to the same thing. I did this one writing the here's the things that we don't want, and now for this one I'll use the not equals. It doesn't really matter. Either way, you'll get the same list of non-permissibles at the end. Divide both sides of this by 3, and you get a is never allowed to be 0. So that's one of our non-permissible values. Another would be if a minus 2 equaled 0. So we'll say a minus 2 is forbidden to be 0. Add 2 to both sides, and you get a is never allowed to be exactly 2. And over here, well, you could take this denominator and say 1 is never allowed to be 0, but that never happens. 1 is equal to 0 exactly never, so we don't have to worry about that denominator. However, if we were cleaning this thing up, we'd have a minus 6 over 3a minus 2 times, and then we'd flip this so the 1 would end up in the numerator and a plus 3 would end up in our denominator now. So there's a new thing for us to worry about. A plus 3 must never be allowed to get to 0, which means a must never be allowed to get to negative 3. So again, there are our 3 non-permissible values. Both of these examples had 3 NPVs. Sometimes you have none, if you're lucky. You can have 1 or 2 or up to 1 for every factor in the entire expression, so don't expect a specific number. Just work methodically through your denominators and look at every piece. 3a is a piece, a minus 2 is a piece. The 1 was a piece, though it ended up being irrelevant, and then after we manipulated this, a plus 3 ended up being a piece as well.